Okay, we are good to go. So two things that we have is OLTP and OLAP, again theory for today. And OLAP is your online analytical processing, online transaction processing is your OLTP. And as a data analyst, 99% of the times you are working with OLAP, which is your particular data that is aggregated, stored somewhere, mostly like it is not live mostly. It is stored somewhere, like it is kept somewhere. I have the data of 2023, it is stored here, you can fetch it. OLTP on the other hand is the live transactional data, like your UPI, your bank, your order ID table in Amazon, your Facebook, your Instagram mostly. So day-to-day transactions are happening and it is current, it is up to date. You have to write simple and short queries. The transaction speed is very, very high. Normalization is very high. An example is your banking transaction. OLAP, on the other hand, stands for online analytical processing. So here it is not day-to-day transaction, it is the total data. And we have the historical aggregated form of data, like I have the data for last 3 quarters, I have the data for 2023, I have the data for past 5 years. We write complex and long queries sometimes to get the results, right? Fast query speed on larger data because the data is already stored somewhere, and often denormalized. Sales analysis over 5 years is an example of OLAP. So that is what is online analytical processing and online transactional processing. Not something that you will go through day to day. Mostly you will be working in OLAP itself, but again, from the interview point of view, these concepts are important. Someone might ask you. Now, there are actually 4 categories of where we can define SQL in, and yeah, and one of them is DML, that is data manipulation language. You can manipulate the data. Second is your DDL, which is data definition language. Third is your DCL. Fourth is your TCL. So these 4 commands are there, and one thing to keep in mind that as an analyst, 90% of the time you are working with DML, data manipulation language, that is used for manipulating the data, like adding, updating, even retrieving the data is something that you would be doing a lot of times. So data is already there, database is already there, you can manipulate it. Okay, you can retrieve the data, you can add a new table, you can modify the table, and you can remove the data. That is your data manipulation. Example is you go to an ATM, you withdraw money, the system updates your account balance using the update function. So update is the example of a data manipulation. These are just different categories of how we can operate SQL in, right? So that is there. Second is data definition language, which is something that mostly is the role of a database administrator to create the databases, to alter the table, to delete the table, and to truncate. So don't worry about what is drop, what is truncate, what is alter. We will understand all these commands. But as a data definition language, he can create things and he can delete the complete data, right? When we say in data manipulation language, we have delete, we can remove entries from the data in data manipulation language. In data definition language, I can completely delete that data from the schema itself. Okay, so in delete, let us say I have the employee table. I can delete this employee because he has left my organization. In data definition language, I can just completely remove the employee table. There is no employee table anymore. That is your data definition. So you can create tables, you can alter the tables, you can uh, delete the tables, you can even delete the databases. In data control language, it is more about giving the control or the access to the person who can view the data or who can modify the data. So there are basically 2 commands: grant, that I grant you the access; revoke is to remove the access from the user. So sometimes in a document like you have in Google Drive, so there is a view only, there is a edit access that you can give to other person. Same is the case in SQL. The 2 keywords grant and revoke are used. Grant is used to give the access, revoke is used to remove the access. Okay. And last is a transactional control language, which is commit, rollback, and save point, that is used to manage transactions. Okay. And again, as you know, transaction group of SQL operations that must all succeed or fail as a unit. ऐसा नहीं होना चाहिए. This should not happen that out of the 10, 6 are succeeding and 4 are failing. Either if these 4 are failing, then this 6 also must fail. Right. An example is commit, save all the changes, rollback, undo all the changes, or save point, like set a point where you can save the transaction. Like this 6 has happened, now other 4 are waiting. But in case after this save point, if these 4 somehow are cancelled, then you have to go back and you have to cancel these 6 also. Okay, this is example of transaction control language. Okay. Okay. So now we will understand using this particular example how in a small online bookstore we can deal with DDL, DML, TCL, and what was the fourth one? Can anyone quickly tell me?
DCL.
DCL. Okay. So now can you guys in the chat box, anyone quickly give me the definition of all of these 4?
Data modification,
data definition, data control,
And
and what
data
is
control,
left?
data modification, data definition, TCL,
Manipulation.
Data manipulation.
yes, so M is manipulation, not modification. DDL is data definition language. Manipulation language, control, transaction control, and data control. Okay. Now, in this example, we will understand how they will work in real life. So imagine you are running a small online bookstore, and that is how Amazon actually started. If you don't know, Amazon initially started as a bookstore, and then they created this empire of all the products they are selling across the world. But they started as a bookstore, online bookstore in US. And let us say you have a relational database system. You have books, you have customers, you have orders. You have a book table, you have a customer table, you have an order table. In the book table, you have the title of the book, author of the book, price of the book. In the customer table, you have name and email of the person, of your customer. Order table will have all the orders that have been placed. Now, someone in chat box is writing data definition, data manipulation, transaction control, data control. Yes, exactly. Correct definition. So, one by one with examples. First of all, data definition language. We will have to define. What we will have to define? The tables. So we will create 3 tables, like I want the book table, I want the customer table. So I will create the table. That is your data definition language. You will create the tables. You will write the fields that I want to have a name, I want to have a email ID of the customer, I want to have author name of the book. This is the part of data definition language. Data manipulation language will come into play when you will actually insert the things in your table. So table has been created. My first customer has just arrived. I will insert the details like name, Sachin, and then email ID Sachin123 @Yahoo. So this is your data manipulation. Now you are inserting. If he comes back again that my email is incorrect, I'm not getting the mail, I will update it Sachin123 @gmail.com. If someone, let us say, is not a part of my bookstore anymore, I can delete his details also, right? But if I want to if I'm closing my store and I want to delete everything, then it is back to data definition language. Then third is your transaction control language, right? So if multiple operations need to happen for an order, you ensure all changes are saved together using commit. If something fails, you roll back to undo the changes. So let us understand this example here in terms of a bookstore. Let us say I have one book that is a particular novel of, let us say, novel ABCD. Right now, I only have this single book. And what happened? Someone purchased. So order table is getting updated that this book has been purchased. But the inventory table that is storing the book is not updated. So now what will happen? It will again show me that the novel is there, but it has been purchased. So someone will come again, he will try to purchase it again. It will show that the novel is there, but he will not be able to purchase because in actual one, someone has already purchased the novel. So if someone has purchased the novel, then this should also get updated. And if the transaction failed, if he's not able to pay the money, if his money is not deducted, then this should not also happen. Like let us say, if the purchase did not happen and the details like the book got updated, then what will happen? The book is there, but in my data, it is showing that book has been sold. So I'm not able to sell it because I did not get the money for the same. I hope you understood this book example in transaction control language, that if the book is sold, then it should be updated in the product table also. If it is not sold, then it should not be updated in the product table because there would be a mismatch of orders. Something that has been ordered would be ordered again, but it's not there. Right. Sometimes it is showing that it is not there, but it is actually there because the order did not take place. So that is your part of transactional control language. And DCL is your data control. You can give the grant to your customer data, not to everyone, but to only certain employees. Like your HR can get the details, or not even HR can get the details of customer data. Only the person who are dealing with the customers can get customer details. Right. So that is your grant. Your let us say someone who orders the book can get details of the inventory data, like how many books are there, how many do we need to buy, right? What is the stock of books? But customer details, you can revoke the access to the person who is ordering the books from the marketplace. So I hope DDL, DML, TCL and DCL is clear to you. What are they and why they are used? These are not like separate languages. They are just part of SQL. Someone is
Can
writing
you please repeat DCL once?
uh,
Last one, DCL.
DCL. Okay, so I will repeat both TCL and DCL in chat box. Someone has written TCL. Here someone has written DCL. So first of all, DCL is simple. I will explain DCL first. It is grant and revoke. So let us say I have this library management system. So what details do I have? Let us go back and see my table. Right. So I have this books. Okay, I have this books table. I have the customer table, and I have the order table. Now there is a person who is working in my store, and his job is to order the books. Like he will check, this book is sold out. We need to order this stock again. Right. Now this person, I will give him grant to the books table, but I will revoke his access or will not give him the grant for the customer table because these are personal details of the customer. He just have to order the book. Why do he need the customer table detail? Right. So I can grant the access to people who are dealing with customer, and I can revoke the access if they leave the company or if they are just there to order the books. That is your data control. You can control who has the access, who does not have the access. Okay. So I hope DCL is clear.
Yes, sir.
Okay. Now TCL again, I think someone want me to repeat the TCL example. So let us see here. Okay. Let us say there is one book that is Harry Potter, right? Harry Potter. And what is the transaction here? Transaction is I make payment, then it means I purchased book, which means that book out of stock. This is the transaction here. The transaction is clear. Because there is only one book, I make payment, I purchase book out of stock. Right? The transaction is clear to all. Now, let us say only this part is successful, only this part is successful, and this part is not successful. What will happen? I made the payment, I purchased the book, I go back with my book. But in the database, this part did not get executed. So book is not out of stock. It is still showing Harry Potter in the stock. You can buy Harry Potter. I will try to buy Harry Potter, but the people won't be able to find it because someone made the payment and took the book home, but the database was not updated. So if these two have occurred, then this should also occur. Either all of them should fail. So if the book is not getting out of stock, the payment should fail and he should return the book. That is what the case is about. Let us say, reverse scenario if we take. Let us say that payment failed, but I showed book is out of stock. So payment failed, the person could not get the book, so he went home. Book is still out in the stock, but book out of stock got updated because this part of the transaction got a tick mark. This got updated, but book is not there because book is there, but the database is showing book is out of stock. So that is now an ambiguity. So if all of them are occurring, then it is fine. Either all of them should be failing. That is what the idea says. Clear now? Okay.
Yes.
Yes. Okay, great. Now, moving forward with data types in SQL. Now, whenever we are storing data in SQL, there are different data types that we can use, right? And these data types are what type of data is stored in a particular column, right? So let us say I'm storing phone number, then it is mostly numerical data. The amount is also numerical data, but amount can be in decimal. It could be rupees 27.5, right? But it cannot be 9937.276. This cannot be a phone number, right? So this is mostly integer value, or even character is fine. When your name is there, then it is different value. So to do it, we have different data types in SQL, and first is the numeric data type. Simplest one is integer, that can only store integer values like your age. Float and decimal can store decimal values like price, weight, right? So that is float and decimal. I hope this is clear. This is very simple to understand, right? Integer and float decimal. Now comes your string data type, which will you will have to look a little bit more carefully here. So there are three data types that you can see: varchar n, char n, and varchar n. Now what is this n here? This is the length of the string up to which you can insert. So if I say that the data type is varchar 5, then you can only insert up to 5, which means you can insert Goa, you can insert where, but you cannot insert let us say Hyderabad. Why? Because Hyderabad is more than 5. So this n is clear to you. By this n, length of the string you can define. So if I want a name, I will define 40 or 100, because varchar 100, no one is having a name more than 100 letter now, right? Now the difference between varchar and char is that character has fixed length, varchar has variable length of string. So fixed length mean if I say 2 letter, then you can only insert 2 letter, not less than 2, which is useful when we are dealing with mobile phone numbers or let us say country code, right? So if it is only 2 letter, then you can only write 2 letters in the same. Pin code can only be 6 letters, 1 2 3 4 5 6. So you can define a character 6. Okay, so I hope varchar and char is clear to you. Any questions in the same? Okay, I hope no. But one thing that I want to clear you, how n is the upper limit, like you cannot insert anything above n. But in varchar, if let us say in varchar, if the limit is 5 and I write Goa, it is completely fine. But in char, if the limit is 5 and I write Goa, then what should happen according to you? Because the length is fixed, it should be 5, but I only inserted 3. Then what should happen in case of character? In case of varchar, it is completely fine. It could be 1, 2, 3, 4, 5, does not matter, should not be more than 5. But what in the case of character? Anyone want to guess? I'm just asking, like, what do you think should happen in this case?
Maybe it'll throw an error.
Okay, so the most logical
It will
argument is
add
that
extra space. For example,
yes,
Goa
it
then
will add
is it two
extra space.
spaces.
So most logical thing that comes to our mind is that it will throw error. But mostly in SQL, what happens is if let us say I am defining a 5-character string, 1, 2, 3, 4, and 5, and I am writing here only Goa. So Goa. Now with varchar, this is absolutely fine. But with char, I have already allocated 5 letters. It has to be 5. So what SQL will do, it will just add 2 extra spaces here. So you will see only Goa is written, but actually it is Goa space written there. That is what happened in character. So only use character when you have fixed length. Otherwise, this thing will add extra memory and it will waste your space. Instead, use varchar. If the storage is 3, it will only allocate 3 spaces of memory and your data would be saved. So this is the example between char and varchar. And your third is nvarchar. So nvarchar is actually an extension of varchar only, which helps you to store Unicode data. So if you have, let us say, some Chinese script like hashtag or some, let us say, Indian symbol or some, in sometimes they write O dash, sometimes in Turkey and some countries they like O dot dot. So these kind of things sometimes might not be supported with varchar. So you can use nvarchar to have multiple languages, multiple script kind of things. It support more symbols than the conventional varchar. But again, it takes more data space also. So unless you require, then only use nvarchar. Otherwise, varchar is completely fine. Then your date time format is there. So by default, the date format is year, month, date. So you will not write like 28/10/2002. You have to write it in opposite. So you have to write 2002, then 10, then 28. Okay. Then time is stored in hours, minutes, and seconds. And date time is a combination of both that you can use to store date as well as time. Real life example, let us go back and do all of them. So from here, for varchar, real life example is when signing up for account, your name. Your name could be 5 letters, could be 8 letters, could be 10 letters, anything. So we use varchar. Character, country code. So if it is fixed to 2 letter, if pin code is fixed to 6 letter, then we use character. nvarchar when dealing with multiple languages, English, Chinese, etc. And in date format, you will use date to when you are filling date of birth. Time when you are booking a event. Like let us say your reporting time. So it will write as let us say 08:30:00, which means 8:30 in the morning. It could be 14:25:00, which is 2:25 p.m. And date time is mostly used in transactions. So when you make online payment, you will see in your receipt there is date and time of the transaction. Both of them are there. So we use date time format. These three are clear. Any doubts, any questions in this? Okay,
No.
great. If no, then Boolean is the last data type in SQL. And Boolean is basically true and false. Boolean is basically true and false, like yes or no, 0 or 1. Right. So 0 is basically false and 1 is basically true. That is what it stands for, and we use it sometimes. So let us say if we want to have binary variables, let us say we have this category where you can either write yes or no. So citizen of India, Yes or no. It could be your undergraduate. Yes or no. So it could be only two things that you can insert, right? So that is your Boolean data type. In SQL Server that we would be using, which is, as I've told you, Microsoft SQL Server. It does not directly support Boolean. Instead, it is written as bit. So in Boolean, we write true and false. In bit, we write 0 as false and 1 as true. So that is the only change. So let us say you want to store in your database who is your subscriber and who is not. Right. So you can write 1 for subscriber, 0 for normal person. This kind of data, when you're dealing with binary data, you can use bit data type in SQL Server. Okay. Now moving forward with SQL constraints. And there are some constraints that we can forcefully insert in our fields. For example, if you go through some form applications in Google Forms, sometimes you say it shows you that you cannot leave this column, you have to fill it. Like if you are signing up on Google, then you should have a username. You cannot skip sometime email, sometimes you have to fill your PAN card number or phone number. That is compulsory details that you have to fill in. So that is constraint that they have inserted. So here we would be discussing the types of constraint, what they are. First is your not null constraint. It means that it cannot be left empty, right? So in an e-commerce website, email field cannot be left empty. So they will enforce a not null constraint. Second is unique, which ensures that a value in a column are unique. No duplicate values are allowed. So in a user table, the username column should have a unique constraint. Another, can you give me a real life example of not null and unique constraint? Not null constraint where you can see. See, unique, I'll give you example. So your Aadhaar card has to be unique. In a bank account, the account number has to be unique. There cannot be duplicate account numbers. Your PAN card details, PAN card number has to be unique. Employee ID is unique. Can you
In
give me
O-
similar?
in ODA ID should be unique.
Yes. In not null constraint, what could be there? A lot of things. So if you're filling a job form, can you leave your name as null? I will not write my name. I don't have a name. No. So there would be a not null constraint. You can not leave this column as empty. Now, primary key and foreign key is what you will deal with mostly in the databases. Not null and unique, you understand? Good. But mostly we deal with primary and foreign key. And primary key is something that we use as a unique identifier, which is a combination of not null and unique. So whenever there is something that shouldn't be empty and is unique, we use primary key, and one table can only have one primary key. So in your school data, mostly your admission number is your primary key. In your government record, your Aadhaar card could be your primary key. In your income tax department, your PAN card is your primary key. So primary key is the unique identifier, which is not repeated, which is there, and I can use it to identify someone or a particular row, right? It is unique to every particular row, and it is there as a first column in most cases. So for employee, it is employee ID. For order, it is order ID. For product, it is product ID. And that is how it works. So mostly your ID column is the primary key. There can be only one primary key in a single table, and it by default is a not null and a unique constraint. So if I say this is the primary key, it cannot be null, it cannot have duplicate values. Second is your foreign key. Now foreign key might take you some time to understand, but when I was telling you that we are creating relationship between the table, right, then we are using a foreign key. So foreign key is nothing but a primary key mostly in another table that matches the value. So let us go back to a certain example and understand it. And our example would be here, right? Now in these three tables, can you tell me what are the primary keys? Here, what is the primary key? Department ID,
Department ID
right?
and project ID.
Project ID. Here there is no such thing. So let us say employee ID is the primary key here, right? So we have 3 primary keys in 3 different tables. There can only be one in one table. Clear? Now, the column